Any questions? Oh, this is now. I need to spend this time, 10 minutes or 15 minutes. Any questions, confusions, intrigues, fascination, bothering? Tell me. Quick. Something that bothers. Welcome, Sankhival. Good seeing you.
Yes, sir.
Thank you very much. Showing you. Anything that bothers you, confuses you, frustrates you, intrigues you, fascinates you, like that, something should be there, right? You can't say no. You can say fascination or intrigue.
Always our programming is very different compared to the Python, like that.
So, okay, very different. What is the conclusion? Different. You want to say the word different?
Yeah.
That is not expressive. Different means different. Could be bad, good, but I want more specific word. These are the words you can use. Confusing, frustrating, fascinating, intriguing.
No, it's fascinating.
Fascinating.
Okay, I can say it's fascinating.
Okay, good. Fascinating is good. Go. I gave you these words. You can use any one of those words. These are emotional words. I want to hear your emotions about the course so far. No, I didn't hear you, Rajan. You said something. You said something, I know, but I didn't hear you.
Oh, nothing. I was just talking.
Something that you...
Go ahead. I wanted to say, somebody say something. What is that? Come on, guys. What is this? Rakesh, are you looking for a word? I gave you the words.
No, I'm not looking for them. I'm just trying to
balance which one is the ranks high.
Yeah, I'm ordering it in my mind.
Just say it. It's okay. Something should be,
Yeah, from PA1, it was a huge step up for me. This PA2, in terms of concepts and everything, it was good. It was good for me. So till now, I'm clear with what is happening. So I need to work on more data sets and more things to. I will have doubts. I will come back. I'm sure about that.
Okay. I want you still to come and use the words I gave you. I want you to use the words because that it is more expressive. It is more emotional. I want to hear your emotions. Do you remember the words I told you, everybody?
No.
Come on. Intriguing, fascinating, bothering, frustrating, exciting.
It is exciting for sure.
No, last word says means that's the only thing that returns in your brain. Okay, come on.
I wanted to say fascinating, but exciting is the more appropriate word for me. Yeah.
Okay. Next, Rajan, I am not able to hear you. I can't hear you. Sharanya, go. I can hear you, Rajan. Maybe you're talking with somebody else.
Oh no, I said it is abysmal. Something bottomless.
Okay. Why?
Learning keep going on, so it looks like it's
introducing new topics.
Say again?
Is it because I introduce new topics every time? Is that what it is? Bottomless. It keeps going. You thought it's the end of it. It keeps going. You thought.
Yeah, there are multiple nodes, and each node has got it's all like clustering here. So I should say like that. Okay, so that's pretty dark, pretty dark. Okay, I'm sorry to hear that. You should enjoy this, right? Learning. If you're not enjoying it, I think it's I got to speak with you separately. What's going on, because I want you to enjoy. You come here every day. I know. Not every day. Those days. No, it's enjoying. It's nice. The only thing is, it's like
demanding more.
Yeah, I feel like that. It's kind of demanding more. Okay, so that's like it's demanding more from me too. I got to tell you. Okay, because there are a lot of issues that are happening. There are changes. I have to make sure it's it's getting my codes are getting adjusted. Things like that. I have to verify code from somebody else who published it. Seems to work at that time, and so on and so forth. So there are issues on my side too. Okay,
But we together as a team should enjoy learning.
Why can't we have an application which is so user friendly that you just say, hey, you know what, just copy this.
Right. You know what? I'm seriously going to tell you, it's $1 billion opportunity. Seriously, okay? Maybe multiple $1 billion opportunity, not just $1 billion. Okay. So it's about how to make modeling very easy. That's what you're saying, and very easily expressed, very easily communicated, right? And you don't have to worry about it, writing the code. You just tell the command, it just gives you the answer. But you only struggle about interpretation. That is being human, right? I understand that. But if we can create that, I'm telling you today to this class, if we can do that, it's a $1 billion company. Are you ready for a $1 billion company, Rajan?
Yes, I'm going to work on that. I've looked into a company who's going to venture into that, and I'm working on this project. If it's through, then I should be working on it.
Okay. So, okay. I closed it, the window, hopefully it will reduce.
But using AI though.
No, the transition, again, this is a very important comment I'm making, everybody hear this out. Transition from what I teach you to creating an app that understands, various configurations, systems, various needs, various, setup scenarios, and then giving you the right answer is AI, which is basically an automation issue, which is basically a programmatic automation. Okay, but then the constructs, the situations, scenarios, right? Data issues, those are the things that are going to be the input to that system. And the algorithmic methods that we learned. Okay, so it's there, but of course you have to learn a little bit more on automation. Yes, last time I talked about JavaScript, there is a need for that too. Node.js, there's a need for that too. So if we need to do those kind of things, yeah, it's a full stack issue. It's not, one thing, you can solve the problem. But it's all within your limits. I don't know. It's within our limits. It's a matter of focus. It's a matter of commitment. It's a matter of commitment. So, I understand. I probably should spend more time with you to explore what's going on, and maybe we'll talk offline also. Okay, thank you. Next, Charanya. Now, every class I usually ask, but sometimes I don't, because there's also limitations. We want to be, but it is important to hear out. In fact, I ask with specific questions, specific statements. Okay. All right, go ahead, Charan. This is the reason why I feel that way. Okay, go.
Sir, I feel that it needs a lot of effort, and I find it very, very interesting, sir.
Interesting. Okay.
And a company named Centric, I was shortlisted yesterday, sir. It was for data in some role in data science, sir. They asked question from statistics, and I think the interview is after 1 or 2 weeks.
Oh, okay. So, but they were all basic statistics.
So the first round questions were all from statistics only, sir.
Okay. Good. Okay. All right. But okay, for this group, working with me specifically. So you talked about beyond, PA1, PA2, and ML, which we haven't gone there yet. ML, the machine learning is coming, machine learning and AI topics. So that is true. In fact, it's interesting is the keyword I take from this. Okay, and also he said, no, I have to work hard. I need to put more time, and that's a very important thing. Everybody has to do that. Okay, but then something extended topic came out that yes, in practice, you still have to know the foundations of statistics. Absolutely important. Okay, don't there is a tendency to undermine. Potentially. I can't hear you, Rajan. I don't know whether you're speaking with somebody else. Okay.
Sorry.
Okay, all right. So there is a tendency to undermine the importance of statistical principles, statistical thinking. You can't do data science unless you are really good at statistical principles because the data is about uncertainty. It doesn't matter. Even AI deals with uncertainty. So that's why AI is not a rule-based engine. And finally, they figured out. Initially, AI world tried to, build AI machines, AI paradigms, solutions on the basis of rule-based, solution. But it won't work. It will not work, and it didn't work. And then they came up, okay, uncertainty is because uncertainty is fundamental. You cannot avoid that. But then we solve the problem of uncertainty by throwing in more data. That is what is happening now. Okay, it is still, decision tree based, but then now I have my decision tree n nodes. It can be millions of nodes, n nodes, and that is possible because we have more data. So we kind of, warp the challenge of AI into a more of a data problem. You know what I'm saying? But it's still the problem is the uncertainty in the data. But if I can find 99% of the situation, 95% of the situations as a purely data issue, that means more and more I give the data, the AI is going to solve the problem. Then the problem is taken care in a way, right? So that is why, AI is able to, now take its new avatar and it is able to succeed. To answer you, yes, statistical principles are foundational, fundamental. You have to set utmost clarity. Few things you have to really be good at it if you want to commit to data science. That is, think think and understand and express or communicate the statistical challenges of data. First point. Second one is know how to write programs. You got to do that. If you are a manager, I tend to interpret Rajan and Raja as manager. They're coming from a managerial perspective. Okay, I may be wrong, or I may be missing other people who are coming from managerial perspective. Maybe Saktivel, maybe Rakesh or Sharanya. I don't know, Soumya. But the thing is, you got to know how to program. Otherwise, managers, they will have people to do the work for them. Okay, but you got to know. In fact, I think I mentioned this. I'm not sure I mentioned this in this group or not. In this new modern world, if you are working on technology, even if you are a CEO, you have to know the program. That's a reality. That's a level. Bill Gates knew. It's not that he did not know. Afterwards, in fact, he started it, right? Programming. The guy really set the tone for the organization. The vision. But he fundamentally was actually a programming work. He was a crazy programming work he was doing. It was unbelievable. He created solutions about traffic patterns, early in the game. One of the first solutions he provided when he was a school kid, occupying the computer room all the time, he was a geek, so-called, it's not a bad word. It means, basically focused on, studies and fascinated by studies and fascinated by technology and, this and that. It's not a bad word. It's a good word. Geeks rule the world. Okay, geeks rule the world. So even if you are a CEO, you got to know programming. Otherwise, you will not be able to drive and think from the perspectives of the developers. And this world is all about development. It's not about doing a farming and then harvesting and selling it. It's a different world, right? It's farming of data, and data is the king. Data is the new oil. Okay, I did not hear from Soumya. And Raja, just jump in. Go ahead, Soumya.
So definitely fascinating and exciting. I'm really liking the courses that I have been doing with you, but it's just that I'm not getting enough time to do. I just do whatever you are doing in the class, nothing extra right now. I'm not getting time to do that. So I just hope that in the future I should be able to read little bit more to be able to understand the concepts little more better. So as of now, I'm just doing whatever you are doing in the class.
If you can do that, that's great. There is so much. I actually bring it up to you. Believe me, it's a lot of material from Peer 1, Peer 2, and then there is more coming. Actually, another At least I'm thinking a little bit more. Including today, there is almost still 40% left out what I want to give you. I don't know whether it's any way. I think it is some way related to what Rajan was saying. Bottomless pit, it keeps going. I don't know. Or it may be some challenges you're talking about, Rajan. We'll come back and I'll talk to you about it later. So Raja, that is true. Everybody has to commit time. There is nothing less. You've got to do it. And I want you to do it. When you go and talk the language of data science the way I teach you are going to be somewhere else, in my opinion. I believe, and remember, every year you are going to keep building this, and you are going to be somewhere. You will be leading and, leading a big group of data scientists and AI solutions potential. Okay, but it requires your time. Absolutely, it requires your time. And I'm asking you to do even, committed to learn programming in a very strong way. You should be excited to learn programming. Always be ready. These top 100 commands, how to use it in R and Python. And then, of course, what is that? Possibly Node.js and JavaScript too. Okay. So, and, anyway, so absolutely, those are the expectations. I want you to give that to yourself and be the leader you can be in data science. Okay. All right. Go ahead. Last, Raja. Mr. Raja, sir, go ahead. How are you? I can't hear you. I can't hear you.
Are you able to hear me now?
Perfect.
Okay, I think there's some issue with my headphone.
Okay.
So yeah. Anyway, so yeah, it is definitely fascinating, right? And the bottomless thing is, of course, right, like what Rajan mentioned. Yeah, I think more time is required, right, to actually go into this one, because yeah, like I think what Soumya said, right, I actually agree to that, right, also from my point of view. Just able to hold on in terms of whatever is being taught in class, not so much able to spend time outside of this more than I actually like to. That's been a bit of a struggle from my side, because weekdays are pretty tough actually, and weekends, I think, right, spend about 6 hours over the weekend, and trying to also do some catch up over the weekend between other things. So definitely fascinating, and like you said, right, this is something that is for the future as well, right? And what also, at least from my own experience, I'm noticing, right, predictive analytics as a topic itself, right, not a lot of customers actually share it outside of their own teams. Okay, which also gives a lot more opportunity for people to get into it, because you get into the green. So
very good.
There is a lot of opportunity actually.
Yes,
Now,
absolutely.
we can argue about R, right? Because I think a lot of people are moving a bit away from R, more into Python, right? In terms of usage and application. But if you are hands-on and you know development, I think you can adapt. That's not an issue at all. It's more about the functions, and I think, at least from my side, right, what I've seen is R brings a lot of these libraries and functions that are pre-built. From historically, at least from where I came from, used to code everything on our own, right? Build our own functions and all that and use it. But here it actually comes on its own. And it's also about trying to understand what to use when, because that is also something I think we are trying to learn as we go along. Some of the things we say, okay, we can do this way, like do you say CORR or do something else, right? That I think probably comes with more.
Yeah, you're right. The reason advantage doing Python, because Python has been it's a much easier language, relatively easier language to learn among all other languages. If you rank them, I think relatively easier.
That's what I heard. That's what I also heard actually, but I've not actually gotten into it yet.
So that's one point. You are right. The other point is Python has been supported heavily by computer science people. So what happens if there is any deficiency, they jump in, and develop that faster. Trying to catch up with as good as R in terms of R functionalities. Okay, but then Python has also it's a more general purpose language. You can do other things also with Python, like, database connectivity or website, management, all kinds of complicated solutions, that are more systems oriented. You can do that very easily with Python. And it is always, it's written in C. Even R is also written in C. But the thing is, the focus of R is really about solutions, statistical solutions or data science solutions. But, Python goes beyond that. So there is a benefit, and people like that because they think that one language can do this, all these things, right? That is an advantage. So, but then there is some elegance, some, relevance in R. But, I certainly encourage you to do only if you like Python, just do it. But I spend time on R because, I'm coming from the solution side, traditionally having trained for 20, 30, 40 years now into statistical thinking. It, transformed into data science. But I certainly appreciate if anybody wants to move in the direction of Python-based solutions in, in data science. What all we did are available in Python also. Okay. But some of the, as I said, I don't know whether you are all following me. There is a problem the way terminologies are used in Python for data science purpose. I'm saying, for example, I think I recently made a comment about that in LinkedIn. That Python, a particular solution is called, in a way that is not the right terminology, because that terminology has a different meaning. Okay, in general in data science. Okay, it's only misrepresented in Python. But these are far and few between, if at all happens. When it happens, I tell in the message also that please make sure that when you apply, this is what the meaning of this is, and you should not interpret it in this way, and be watchful. That's all the main point. So otherwise, you are good. Everyone is good. If you want to just follow Python, do that. And I can only spend so much time, so I don't do this or code is this and Python. But maybe there will be a time I will be there. But I just use wherever I can. I use R, and if I want to use Python, I also do that. In fact, in machine learning AI topics, for example, the reinforcement learning, I show it in Python, for example. Okay, so so that's an important point also, Raja. I leave it to people as you grow into
the point is, it's not about R itself, right? And like you rightly said, right? Anything in terms of statistical usage and all that, I think R is the language to go, right? Python maybe is more broad-based. Just that I think because it's an easier language, a lot of people are having an affinity towards that. But also for all the people, right, that are there, there is all this, not only the depth, right, but also the spread that we are seeing, right? Because each person comes with your own set of tools and languages, right? I'm just trying to look into like Google Cloud. They have their own set of languages even for machine learning and all that, right? Which is something that people have to keep learning. It's not about being stagnant like how it was like 10 years back. Even if you say Java, okay, maybe Java with Oracle, or that's where you are, right? Maybe around that, right? But now it's much more in terms of the spread is there, which I think people have to keep learning. So
yes, that's another point. Yeah, we all have to learn. Unfortunately, keep learning.
Yeah, that's true.
That's also another issue too. You are right. But I mean, it's an important problem for others also. That's why I spend time here. Okay, what Raja is saying, there are some challenges, but we all have to commit to one area in life. You cannot be a physician and do this, for example. You cannot be an engineer, mechanical engineer and do it. You have to be a data scientist. You have to be, data science is opening up more opportunities. If you want to be in AI, machine learning, this is the entry point. You do this work, eventually you will graduate to that. But then it's not going to be the end of it, right? As you said, okay, you do all these things, but if you want to implement the solution, you have to go to the cloud. And are you going to use a GCP, Google, or you're going to use Azure, or you're going to use AWS? Everything has its own, interconnected, connectivity issues, topics, you know, the application issues, you know, the identity management issue, right? Right? Identity management issues. So you have to keep learning it, but hopefully this is the reality, because I face those situations also. Hopefully that because you commit that, you know, your focus is there, and you will have to focus on very small area of application to develop a world-class billion-dollar solution. Imagine, correct? Okay, just focus on that. It's a challenge. I face it every day, you know, because I'm kind of generalist. You know, it's a lot more difficult for me. And for you folks, I hope it's not that difficult, because you have something in your mind, you know, about something, one particular solution. It all takes only one particular solution to be a world-class company. And I'm hoping every one of you have this vision. It's not just coming and doing some diploma. No. Think big. You can be the CEO. I'm talking to every one of you, of a company that uses data science as the foundations. There are tons of opportunities, tons of them. I'm telling you today. Okay, so think big, commit to the science, and even if you get once you complete this diploma, it is not enough. You still have to do some additional things. That's okay. As long as you focus on a very well-defined area, you will be fine. Okay. So with that, did I kind of connect with you all? I mean, I may, if I haven't really connected with you, still, you know, let's connect individually. Okay, everybody. Good. All right. How about it?
Yeah, just one point, right? Sorry, this is Raj.
No.
So actually, this is also something I had also reached out to Supriya, right, earlier. So maybe this is helpful for everyone, right? So what I was actually trying to also ask her was, right, so there are multiple different models, multiple different right, analysis approaches, etc., that we have been learning, right? And I think at least not personally also I've been through that, but I think a lot of the other people in the team here is also going through the same, in terms of one is understanding it, and then how you actually apply it also, right, in terms of the steps, and not only R but also generally the steps, right? So maybe a cheat sheet in terms of the guidelines of how to approach each and every thing, right, and also translating it into R, right? Need not be detailed, but at least at a high level, right? Just like before you go to an exam, you have a summary sheet, right? Something like that will help actually. Okay. Actually, that's what I was also checking with Supriya. Something like that is possible. Okay.
I do have something, two things like that. One is the one I have written, exactly, a cheat booklet, which tells you this is the method, these are the assumptions, these are the, you know, why you use it, why you use it. We can add an R code to that also, but we'll come to that one. But this book, I have 18 pages of, you know, this Word document. I get. Supriya, do you have a copy of that? I'm searching for that. We should give this to the people, you know, today. Okay. That is about
help actually. You have something like that.
It's very useful.
Because obviously, like, there are 3 hour recording sessions that we go through, right? And while it is always good to go back and listen to everything, by the time you go to the 3rd recording or 4th recording, you tend to actually lose some of the key points in the first one. Actually, that's maybe more of a learning thing, but something like a cheat sheet will help to at least understand the key things that we can use to apply. Maybe specifically, if we need, we can go back to something detailed.
Okay.
And that's, I mean, personally, I was thinking that will be helpful actually.
Sure. So I'm going to right now give you that one. I think it's a good reminder for me. There are a lot of things, Raja and rest of you, you know, you know, I commit myself personally almost, you know, 16 to 18 hours. 18 hours I commit, you know, every course. It's a lot of personal attention. I didn't get it, you know. I'm in a very proud way. I'm saying that I'm able to give it to you. Okay, at my level, yeah, I didn't get it in my life, and it took a long time for me to come up to this. I don't look at this. I have a great view, right? I have to come up to this to have these kinds of things, and so you know, I'm very happy, proud about it. Point one. Okay, But even then, I have to be, there is only selected number of sentences I can talk. Sometimes I feel, oh, I should have done this. Here is, for example, because you reminded me, I can be able to bring it up to you right now. Okay. Sometimes I worry that I might miss these things. So that's why part of the reason I want to probe you. I want to hear, deep into your heart, what's going on. Are you there with me? And so on. So there is only so many statements I can make in a say 18 hours time per subject. I wish I can talk more. Anyway, so I have to attach the file here in the chat area. Is it possible? Like thought meeting? I don't know. One moment, please. I can't attach it. Huh? Okay, so you know what? How do I do this? Oh, you are not able to hear me? Okay. Let me see.
I can hear you, sir.
You can hear me?
Yeah.
Okay. Maybe another one is going
Sir,
on.
about the document, that one I don't have.
You have this one and comparison of statistical learning, machine learning, and AI modeling cheat sheet PDF?
No, I don't have it.
Okay. I wish why is that in GoToMeeting I cannot attach it? I wish I can just drop in here. No?
The chat box, if you can try.
Maybe right now we don't need to actually have it right now, right? Offline you can probably share it.
Yeah, okay, I'll do that. Okay, that's fine.
Right? Yeah.
Yeah, you can see here.
Right?
Yeah, you can see here, linear regression. Do you see this one? I don't know. Okay, linear regression. And then comes generalized linear model. Okay, the dependent variable belongs to a member of exponential family of distributions. Logistic regression, and then there is more material on the right side. There's some explanations and so on. I think I'd like to do what you said, just to clear some simple R code in the fourth column. Lasso regression, elastic net regression, generalized additive model, decision tree, random forest, multinomial classification model, recommendation engine, k-means, hierarchical clustering. We are going to do this. DB scan clustering, optics clustering, PCA, factor analysis, correspondence analysis, SVM, support vector machine, boosting methods. These are all coming in machine learning. We'll wait, XGBoost, neural networks, deep learning, CNN, RNN, LSTM, reinforcement learning. That's all it is. I'm teaching all of this. Some of them probably spend more time, but, because I want to get to the depth of it, and they are very fundamental. Some of them I spend less time thinking because we have done this. It's easy to own it, So I will send this one. Okay. The other one I have is actually in ML AI. I have another cheat sheet. This is published by McKinsey. Okay. McKinsey also did a very nice job. Only about AI topics. What they call it as AI topics. They did a very nice job, and I will share that too. So both I will send it this time, even though machine learning to be done later. Let me see. McKinsey, which is called McKinsey. So it is in the deck itself, I think, as embedded. Okay. One moment. ML, right? We are in ML. ML complete notes 720, 777. So, do you have that, Supriya? McKinsey's document about summary of AI topics, the way McKinsey did it.
This I have shared with the group.
Huh?
This I have shared. This I have shared.
McKinsey stuff.
This one.
This one is
Recently
just a PowerPoint deck about.
Recently I shared.
This may be PowerPoint deck. No, this is a neural network. This is just a PowerPoint deck.
Clustering? No.
So
Clustering
now
I have not shared.
You have to look at it. I'll do that, but at least send this one, first one, okay, today.
Yeah. Please share this with me.
Good. Don't worry about the time that we spend. I will add more time. It will be a longer session. That's the only thing. If it's okay.
I like the concept where you said, in that cheat sheet, you're going to have a fourth column with the R code in it. like a summarized R code, which will do for each function, that would be a nice thing actually. It will make it, it will give us confidence to do what we want to do. Yeah.
Yeah, I mean, yeah, you see, either you can do, sir, or I think we can together spend some time, right?
There you go. I
So
like
try and put it all together, actually, right? So that it will also be a review for all of us.
I like what Raja said just now. See, that's what I like. If people jump in and say, "Hey, let's do it," no, I love it because there's only so much time. We all have, right? You also have limited time. I also have limited time. I do so many things. I'm not copying out. I'm just telling you. There's so much to do. I just don't spend time there. How nice it would be if I have the R code there. How nice it would be if I also have a Python code on the 6th column, right, Rajan? It is better, right?
Very good.
Very
That's
good.
well better. Yeah.
So these are I think we can all do it together too. It's fun. It's fun. Thank you very much, Raja. I appreciate it. I'll give you the booklet, and then you add something, and somebody can do. Not everybody. You don't need to do everything, Raja. No, everybody can add a few things, right? Hey, I take 3 topics. You take 3. Then do something, right? That will be cool. Very cool. Just do R because I introduced only R because if you want to do Python, it takes time. But definitely we are getting there. Okay, we will continue to improve this. You can use it as a personal booklet maybe, and it will expand. Who knows, right? Because you may need more detail. Let's see. It's fun. Thank you so much, Raja, and thank you very much, everybody. All right. So it took 45 minutes, and it is okay. Don't worry about it. These things we have to talk also, right? Because this is what binds us. This is what binds our thinking.
So just because we're looking at the time also, right? I really have a hard stop today at 8:30 IST. So just letting you know.
No problem. If you have to move, you move. If it extends by chance, I think it's only fair. I will try to put extra time for you guys because you spend time with me. You might be anxious that, oh my goodness, I lost time. Don't feel about it. But if you cannot stay there, you can always listen. Whatever the missed part, definitely. Okay. Excellent. Let's take 5 minutes break. Then we start fresh. Okay. Is that okay? I know, Raja, you are under stress about time. Don't worry about it. I keep talking. You want to go continuously? It's okay, or everybody's okay, fine. 1, yes, 2, like this. 3,
fine.
3, 4. Soumya. Okay, all right, let's go. So now we are going to do clustering methods. Now think, always remember why clustering works, why it matters, right? Why it matters is very simple. Why it matters is very simple because we don't have supervised information, okay? And that is why we need different methods. Clustering is one of the methods, So we have no supervised information, and somehow we have to create intelligence out of it, right? So one of the things is, like many things we have been seeing, there is another thing that is called the grouping method, clustering method, also called segmentation method. Sometimes grouping, clustering also called segmentation. So in other words, if I look at birds, even if I don't know the names of the birds to identify, I can group. Children can do this, right? Even if you don't give them any knowledge about the groups of birds, you can, over a period of time, they will figure it out. And I should figure it out that, oh, these birds have long beak, short leg, wide wings, flies high. You see all these attributes, there are features, they define certain types of birds. We don't know what that bird is, but types of birds. Okay? And that is what we do. But then what helps us to do is some kind of a distance listen very carefully, some kind of distance between the collection of attributes, keep the kind of, let's say collection of attributes, let's say 10, I thought probably in one of the class I already mentioned this. Did I teach you this one? But somehow I remember it looks familiar that I uttered these words to you. Did I?
No, sir. No, sir.
I don't
You
know.
did actually. I think it's
Yes, sir,
regarding.
you spoke.
You did. Okay. Wings, legs, right? Beak.
Yeah, I think the point is,
You did, but related to which one I'm not able to.
yeah, that's what I'm also trying to do. But I didn't teach you clustering, right? I think I didn't teach you clustering.
No.
So
You had mentioned
answer
how
my-
it is.
No, you took this example for the
1 minute,
PC
sir.
also.
You had taken then, and you had mentioned someone had said clustering word, and then you said no, that falls into a different class altogether. So when I'll take clustering, I'll bring that example again. So I guess this example was shared, but not in the same way.
No, so in probably PA1 I mentioned that, or when I introduced the course PA2 I mentioned that. Okay, there are different topics. Right? Correct? Okay.
Yes,
Yes,
So-
sir.
yes.
So the fundamental things. So let's recall those one. Beak size and beak color. Two attributes, two features. Leg size, leg color. That's okay. Leg size, leg color. And then wing size, wing color. Tail size, tail color. Okay. What else? Neck size, neck color. 10 features I have mentioned. So by looking at the different, now instead of difference, we are going to say distance. You can also say difference. The differences among these features among the birds should give me an approach to group them, yes or no. Differences. Very simple, right? Differences should give me the, so one type of bird will have long neck and rest of the features are same as another group of birds. The only difference is neck size. But it's a different group, right? But then I have already 10 features. There are so many different groups you can find. But different groups are basically explained by differences in the whole vector into one measure, one summary, or vector of measurements. The whole vector means this is a 10-dimensional vector, right? Instead of saying differences, we use also distances. Sometimes we use differences. We also use distances. Okay? Difference itself is a distance. If you look at it, it's a distance. Difference itself is a distance. And distance means a certain mathematical properties. Okay? So that is what we are going to do. We are going to use a method called clustering where we are able to group observations. Observations refers to information about entities or things or people, places, things, so observations about people, place, things, can be grouped in different groups based on the data vector, how they differ or how they are distinctly distributed over the measurement space. Is that very good? That is called clustering. Okay, good. Thank you. At least I see you, Sharanya, and then you say like this. It gives me satisfaction. Thank you. All right. So one strategy is, given a collection of data points, find groups among them so that the distances within the groups are minimum and between the groups are maximum. Did you get that strategy? That's one strategy, right? Everybody?
Yes.
Finding groups.
Yes.
Yes.
Finding
Yes, sir.
groups among the data
Yes,
collection of data points so that the distances within the groups are minimum and between the groups are maximum. That is one strategy for which we are talking about. Because I said distances, we need to know how to calculate distances between groups and within groups, and we will do that. K means is one of the great examples. Another strategy is rank the items by some measure of similarity. Some measure of similarity. I didn't say distance here, I said similarity. And based on a cut point, I will create the number of groups. Okay. So, but really the distances and similarities are same type of information in the opposite direction. Distances tells you how different, similarity tells you how close they are. That's the only thing. So depending upon concepts, we will use either distance or similarity, but one is it's really a complement of the other. In fact, the cosine similarity is more about, we talk about how similar they are. We don't say how different they are, right? Cosine similarity, which is same as I told you, is Pearson correlation, except for the denominator number. Okay, people can ask this as an interview question. What's the difference between cosine similarity and Pearson correlation? It's the same thing, but the denominator is different. Okay, but it is coming from the point of view of how much the angle happens in the data vector in multi-dimension. So that's what we are going to do. So one of the common distances, if I have a two-dimensional point, y2 minus y1 square plus x2 minus x1 square, and sum of that, right? And then take a square root of that. This is called Euclidean distance, okay? And that is one of the very, very well-known distance concept. So that's one of the things that we commonly use, but I want to introduce more types of distances because in data science, we have developed lots of different distances depending upon the problems to solve. So I'm going to quickly move on to these things. This basically, that's what we are saying in a graphical way. This is called intra-cluster. Intra-cluster distances are minimized. The inter-cluster, this is the inter-cluster, right? From here to here, some kind of an average from here to the average to here. That is the inter-cluster distance. This is maximized. This is minimized. That is called the grouping, good clustering. That's what a good clustering helps us to do. Okay. But clustering doesn't have to be like this, very circular and so on, right? It could be any kind of strange things, right? So the other thing is, you are given a blob of points and you want to partition them and to create clusters. Okay, this is one way to create the partitioning. But look at these differences. This is not the only way to create clustering, but this also, you can call it as a different cluster. Does that make sense? So the reason why I show this slide is that what all matters is, it's a non-overlapping collection of observations called clusters. But sometimes, very closely, this may be as good as in some measurement of a good clustering, this may be as good as this one. So the number of clusters is always a variable, which is a tricky point. Okay, but there are methods similar to scree plot. You remember, scree plot is used to find out the number of PCA, right, or number of factors in factor analysis. And we use scree plot, but the scree plot is based on the eigenvalues. Remember, the cumulative eigenvalues. The eigenvalues are basically the variances that is, attributed to the specific PCA or specific factor in factor analysis. So we will have a method here also, and like that. So let's keep moving. We will have a method. We'll see. The one of the fascinating thing, useful thing is, K-means is one of them. I told you we are going to do that. There is also another method called hierarchical clustering. Okay, so you can hierarchically keep on, saying that, well, these are closest, but in the next level, if I want to expand, this is the next level. I would say this is the next level, calling it as a cluster. Then P4 should be added to P2 and P3, and then after, if I include the distance, bigger distance, higher distance, then at one point, if a distance I am willing to tolerate the distance between any 2 points is at certain level, then P1 will also join to this cluster. Okay, and based on, remember again, in clustering also, depending upon certain logical thinking, I'm going to show it to you momentarily. Not that this can be starting point, and these two can be a starting point, and then eventually they all get accumulated into one cluster like this. Okay. So two broad groups I'm going to talk to you: K-means clustering and hierarchical clustering. The K-mean clustering is basically partitioning based on mean value of the objects. Okay. Let's do an example. So here is the 8 points. Okay. And so the question is, how many clusters are here, and what find the clusters here. How many is one, and then actually finding that is also the second point we have to solve. So I can say there are 3 clusters here, and then figure out what it is. Like, for example, this looks like, visually I'm saying, this looks like one cluster, this looks like another cluster, this looks like another cluster, 3 clusters. But I said 3. If I say only 2, then perhaps, so I'm selecting the number of clusters. Perhaps this is one cluster, and this is another cluster. Okay. If I have 1, then it's the whole thing. If I have 4, this is one cluster, this is one cluster, this is another cluster, this is another cluster. Do you get it? Visually, I'm making some logical sense. Only visually so far I'm calling in for a logical sense. So let's do mathematically. Okay. So that's what I will explain now. And every time, in the case of K-means, you have to start with some random starting point. There is nothing you can do about it. We don't know what is cluster. And the algorithm has to tell us. So visually, I told you all these answers here so far. Right? Visually, I told you what the answers are, right? But algorithm doesn't know vision. It is going to, right now at least we don't do that, right? Vision is being developed. Still, there is so much to do, and we may have exactly like what I said. The algorithm will figure out visually and then validate it through another method and so on. But right now it's all it has to be done mathematically. So we have to determine how many clusters you want, and then once you determine how many clusters you want, you have to select randomly that many centers randomly, and then start iterating through the process to get the answer. So that's what we are going to do. Okay. So yeah.
Yes, sorry, one question, or rather, right, trying to understand. So we are talking about the clustering methods here, right? So when we look at a problem, okay, what would be our end goal actually? Because I'm just trying to, I know we are talking about clustering and grouping it, right, based on the formula or the algorithm. What would be our objective actually at the end of this? The
objective is to find out the clusters, whatever the number of clusters we committed ourselves. So we say find 3 clusters here. So okay, k is equal to 3. Okay. Now the algorithm will give us those 3 clusters based on a distance measure. So we are going to start with a distance measure. So we need 3 things, right? First of all, the data points. Second one is how many clusters you wanted. And third one is find those clusters, but then we need a tool for that, the distance calculation. So what is the distance we are going to use? Depending upon the distance, the clusters will also change. So those are the 3 things. The output in the eventually, given a collection of data points, you want to separate them out as groups. That's our outcome we have to achieve.
Is it possible to give a example of a problem actually, sir?
We are going to solve the same problem. This problem we are going to solve right now. Ready?
That problem.
Yes. We are going to solve that.
Clustering just for
segregating into groups. Yes, separating into groups, finding groups. That is our problem solved. But this is the example I'm going to I just introduced to Raja. So are you ready? My question is now, are you ready to do those calculations? In other words, it is like an algorithm doing the calculation. Okay, it's not that I do it. It's a process of steps that will accomplish that to you. Okay. So before that, I told you we need to know also what distance we are going to use. I'm going to introduce one possibly unknown distance measure for you. what is called Manhattan distance. Okay, Euclidean distance I introduced. Now I'm going to introduce one more distance called Manhattan distance. It is just Manhattan. It's called Manhattan distance only basically because it looks like the how to find distance in New York City, which is called the downtown area is called Manhattan. Okay, in this case, it's really the neighboring town called Hoboken. In USA, because they developed the city, because they envisioned and developed it, it's not like a city in India or China or in Africa or even in Europe. These are all like these perpendicular streets. And if you want to go to one place to another place, you have to follow a method called differencing, absolute differencing. Okay, so if you want to go, are you able to see this one? If you want to go from the 5th Street intersection with Clinton Street, 5th Street intersection with Clinton Street, and 6th Street and Park Avenue. This is Park Avenue. Okay, so 6th Street, Park Avenue is this point. Let me put that, insert some symbols there so that you can figure it out. So this one, right? Park Avenue, 6th Street and Park Avenue. This is the point. And I'm going to do fill as none, no fill. And then I make it bigger, red color and bigger. Okay, that is the intersection point, and you want to go from here to that point. Let's say this one. This is 5th Street and Clinton Street. You want to go from here to here. If you use Euclidean, you will go directly put a line here and then go. But you cannot do that, right? In going to one place to another place, you cannot walk over the buildings. There is no pathway there. The only pathway is to go all the way here. So how do we calculate this kind of distances? This is called, Manhattan distance, because you have to use this distance method in Manhattan. And the way to do that is, in this axis, the difference. This is the maximum value, this is the minimum value. Then this difference, absolute difference. And then from here to here, absolute difference. That is how you can find the distance between here to that place. There is no other way to do it. Everybody agree?
See, I studied this one subject called GIS technology. GIS technology uses distances in terms of how they navigate from one point to another point, but not using Manhattan means. Does it make sense?
What is the purpose of that application? I don't know what. So
that is your when you're trying to go from one point A to point B, it shows the shortest distance of how you travel. So that uses some technology called GIS, and so that is what they use.
I think remember, it's all depends on the in this case I'm saying, if you want to go from here to here, this is the shortest distance. What I said is the shortest distance.
Yes, in GIS, what they do is they take a lot of variables into consideration. Like if you want to drive, you want to run, you want to go by train or something like that, and what is the available route? Is it one-way route?
That's why this is called a Manhattan distance. In this case, whether you go by car, by bicycle, or walk, doesn't matter. Not flying. Okay.
Like if you go to Google and search for the distance between 2 points, it uses the GIS model only for calculating the distance.
Just check this small example alone. You just check this small example alone in Google.
Yes.
Because for this application, Manhattan distance in Manhattan, this application is only for Manhattan type comparisons. Here it doesn't matter, right? The car cannot go over the buildings. The bike cannot go over the buildings. They all have to follow. Walking cannot go over the building. It has to go only this way. Except flying. I'm not talking about the flying application. So you have to go through this. It doesn't matter the car. In fact, car can be more problematic because what if it is a one-way, right? And maybe you have to go all the way from here to maybe here and then go here and then go here. Then in that case, it still will be the same thing because this distance is same distance and this distance is same this, so it will be same. But what if this is also one way? Okay, it cannot turn right here. then you got to go all the way from go here. I don't know. It depends on the one ways and so on. But car and walking and bicycle, definitely I can share. It should be the same, right? Even car cannot be same in this case.
Okay.
Short distance because the one way is coming into play. I'm not bringing into those one way issues and so on. This is called Manhattan distance. You have to go this way and this way only, and that is the minimum distance. You have to cover to reach this. That is called Manhattan distance, and that is basically absolute differences between this coordinate value, this coordinate value. That is what this one is on one axis, and this is another axis. This is another axis, and that is the absolute difference between this and this. That's what the second part is. So if I take a point x1 y1 2, 10 and x2 y2 also 2, 10, then there is no distance at all, right? It's the same place. So it should get a 0 value, and it will get a 0 value. This formula will get a 0 value. This Manhattan distance formula will get you 0 values. But if you take a point x1 y1 is 2, 10, but x2 y2 is 5, 8, the difference is the absolute difference is 2 minus 5, which is plus 3, right? 3, and then 10 minus 8, that is 2. So 3 plus 2 is 5 units. And remember, you can say it doesn't matter which one you call it as x1, y1 and which one you call it as x2, y2. That's why it's called absolute difference. It is the distance between this point and this point. Okay? And it is 5 units. But if you consider this point and this point, it is 9 units. Everybody agrees with me? 2 minus 1, absolute value 1. 10 minus 2, absolute value is 8. So it is.
Sir, isn't the difference formula root of x2 minus x1 the whole square plus y2 minus y1?
It will not be.
That is different.
That is different. That is Euclidean distance. It will not be. You calculate this value 2, 10 and 5, 8. That Euclidean distance, it will be different. Euclidean distance is a diagonal. Okay, but I'm not talking about diagonal. You are using axis based. You are moving on the same axis and then moving on the other. First, you move on the one axis and then move on to another axis. It's called Manhattan distance. If you calculate like that, it's called Manhattan distance because you can see it's applicable in Manhattan type street constructions here as an example. Hello, Rajan.
Mummy daddy. Oh, sorry, my bad.
All right, thank you. So everybody is good on this calculation. Can I say you are good? It's fundamental because we're going to find the clusters here. Now go keep do this for me. You put these things in your Excel sheet, please. Everybody 2, 10, 2, 5, 8, these are the points. These 8 points. You see this one? These 8 points are actually this 1, 2. This is 2, 5. This is 2, 10. This is 4, 9. This is 5, 8. This one is 6, 4. This one is 7, 6. No, 7, 5. Sorry, 7, 5. 8, 4. Everybody, that's what I have put it in a tabulation like this. Okay, so we want to find out. You take the center to be, and why did I take these 3 points? Because I wanted 3 clusters and randomly chose these as the starting point. Then you might worry that these are the starting points, so our problem is fixed. No, we want 3 clusters. That's our point. That's what our point is, right? The center will change. Don't worry about it. As we iterate through this one, it will change. You will see. So let's find out the distances of each of these points from this 2, 10. That is 0, 5, 12. Already we calculated that here, right? 0. If I haven't done that, 0 to this one. 210, right? 210 to 210 is 0. 210 to 8, 5, 8 is 5. 210 to 1, 2 is 9. Okay, we calculated all those things, right? 1, 2 is 9. And 210, 25 to 210, 210 to 25 is 5. And we can continue to fix this one. Can somebody write each of these one? Everybody, please create this tabulation. And it is very straightforward. We can calculate that here. For example, we can finish this way. I showed you these calculations. Let's finish this way. So 210 to 210 is 0. The same point is always 0, right? 210 to 58 is 5 because 2 minus 5 is 3 plus 10 minus 8 is 2. So 5. 3 plus 2 is 5. Here 210 to 1 comma 2. 2 minus 1 is 1. 10 minus 2 is 8. 9. 1 plus 8 is 9. Okay. And second one is 2 comma 5 to 2 comma 10. That is 2 minus 2 is 0. 5 minus 10 is 5. So 5. Is everybody good? Question? Raja, Rajan, Sharanya?
Yes, sir.
Okay. 2 comma 5 to 5 comma 8. 3 plus 3, 6. Do you agree with me? 2 minus 5 is 3. Absolute value only you have to take. Okay. 5 minus 8 is 3. 3 plus 3 is 6. Likewise here 2 minus 1 is 1. 5 minus 2 is 3. So 4. Now you can complete this one. But what I am trying to tell you is that which point belongs to which cluster. We said these are the starting points of the clusters. These are the randomly selected starting points of the clusters for 3 clusters because we wanted 3. So this point is closest to, always this is true, right? Because this is the minimum value. Remember, within the clusters, they should have the minimum value, right? Minimum intra-cluster distance. So this is 0. So this belongs to 1. Of course, this is very straightforward, right? But next, look at this one. This is not 0, is here, right? So what is which cluster this belongs to? It belongs to this cluster, cluster number 3, because that is the minimum distance. Are you with me, everybody? Any questions
Yes,
so
sir.
far? So we say this belongs to cluster 3. Okay, this belongs to cluster 1. Let's continue completing this. Okay. Next point, 8 comma 4 with the 2 comma 10. 8 minus 2 is 6. 4 minus 10 is also 6. 6 plus 6 is 12. 8 comma 4 with the 5 comma 8. 8 minus 5 is 3 plus 4 minus 8 is 4, which is 7. 3 plus 4. And then 8 comma 4 to 1 comma 2. 8 minus 1 is 7. 4 minus 2 is 2. So 7 plus 2 is 9. And what is the minimum here? 7. So it belongs to cluster 2. This is cluster 2. Okay. All right. So I just do these things. So I found each of these belong to which cluster. The first one, wherever you have 0, it is just talking about its own point. Of course, it belongs to its own cluster. Okay. But rest of them are assigned on the basis of the minimum value. So there is only one observation in cluster 2, 2 comma 10, but there are 5 observations belonging to cluster 2 and 2 observations belonging to cluster 3. Let's go back to the visual. The visual is this. So this is, it's so far from other things. It belongs to one cluster. These things are all together. They belong to one cluster. Okay. And these 2 are closer. It belongs to one cluster. That's why you have, only one observation here, and then 5 of them belonging to cluster 2, and this is 2 of them belong to cluster 3. But the problem is not over. Okay, why? That's where the mean comes into, the meaning of K mean come into play. Okay, that means in this case 3 mean clustering. That's what it means. It's not mean. Okay, it's a good one. K good clustering maybe. Okay, but K mean, we said because it's the average we are going to use. What average we are going to use? We take an average of all these points that fell into the first iteration. We take an average of these points that fell into the first iteration. We take an average of these points. There's only one point. The average is the same point. So now the mean is different from this point. The mean is different from this point. Now we recalibrate the 3 mean clustering. Are you with me, everybody? So for cluster 1, we only have one point, A1, which is 2 comma 10, which was the old mean. So the cluster center remains the same. But for cluster 2, the mean is this is the mean 6 comma 6, which changed from previous mean. The previous mean was this one, C2 point, which is 5 comma 8. 5 comma 8 was the previous mean, but now it is 6 comma 6. For third cluster, in the same way, the mean is 1.5 and 3.5. Do you understand what is meant by the k-mean here now this time? It's a lot more clear, right? Because we keep changing the mean until it is stable. And once it is stable, that means the clusters will not change. Otherwise, clusters will keep changing. So you got a new mean, so you're going to create a new table. These are the new means. 1.5, 3.5, 6, 6, 2, 10. And for the same points, you're going to do the same calculations. Do you all understand what I'm trying to do?
Yes, sir. Yes, sir. Yes.
2 yes, I heard. 1 like this. 1 yes, yes, yes.
Yes, sir.
3,
Yes, sir.
4.
Yes, sir.
Yes, sir.
I didn't hear new people.
5.
Yes, sir.
5. Raja didn't say. Huh? Raja is not here. Oh, Raja is here. Yeah, 5. He said 5. Okay. All right. They will be said. I tell you, they will be said. If you have a problem, talk to me. Now, I did the computation here again. How did I calculate the Manhattan distance between this point and this? Manhattan distance between this point and this. Manhattan distance between this point and this. And this is what turns out to be. And of course, it's the same point. But the mean did not change here. So I'm going to get 0 again. So it is 0. So minimum is 1. So it belongs here. First cluster. But this one is, it didn't change compared to last one. But something changed here. Out of the 4, 1 changed here. This is going to disturb the mean again. Right? Now the third iteration, the mean is this. 3, 9.5. Change from 2, 10. And then 6.5 to 5.26. 6.5, 5.26 is the new mean, the third iteration. The third did not change because nothing changed here. It's the same 2 points belong there. Let's continue to do that. And if you repeat that, you will get now, here this 2 becomes 1 now. I got 3 1 points, 3 2 points, and 2 3 points. 2 3, 2 points belong to the third cluster, 3 points belonging to second cluster, 3 points belonging to first cluster. Is everybody good? You know how to do this, right?
Yes, in the previous.
You want to do it yourself, right? Can we do one iteration?
It was 5 5 2, no, sir. What if it's 5 5 6, sir?
Which is 5?
I mean, like, both are same. The other one is greater. No, sir. In the previous slide, it was 5 5 2, no, sir.
Which is 5 5 2? I'm trying to understand.
The second one, sir. Where the mean change, we have to change the mean because of that, no, sir. The second column, sir.
This is the second iteration mean. This is the second iteration mean. What is your question?
No, sir. In the second row of new center 2, 5, it is 5 5 2, no, sir. What if there is a situation like 5 5 6 or 7?
Which number you are reading? This or this or this?
Second tabular column, sir.
Yeah, this one?
2, 5 new center, that row, sir. If it is some 6 or 7 instead of 2, then what should you do, sir?
It's the same number, isn't it? It's the same number, agree? I didn't change anything.
Distance mean 3.
Her question
Sir,
is,
the column of distance mean 3.
more than one mean having the same distance to the point, which should we take actually? This is the second row. That's her question.
Yes, you're right. Okay. But only minimum matters here, right? I'm talking about only minimum is
Correct. So in this case, if it is 1.5, 3.5,
if you have
right?
Minimum is twice. Minimum is same. If that's what your question is. In this case, it is not. Minimum is, let's say 2. This is also 2, and this is also 2. Then you can random guess, and it's okay. It's fine. We have to do that.
Okay, sir.
We have to do that. Random assignment there. But eventually, it will iterate to their solution, unique solution. In other words, you cannot get two different answers. All right. So that's why we do. Is everybody clear about it? How it is done? And you don't have to do that.
Sorry, one question actually. So after the first iteration, right? You change the mean. How did you come to the the new mean, I did not follow that actually.
No, we basically, so based on the clusters, we calculate the means, new means. So once again, this one. So this is the solution, right, for the first iteration. Now I know which belongs, there is only one observation cluster 1. These two observations belong to cluster 3 and 5 observations belong to cluster 2. We average the values of the data points here. There is nothing to average here, there is only one. So it's still in iteration 2, it is the same mean. But for iteration 2, for these things change. For 3 and 2 it changes. This is the way to calculate the mean. This is the mean calculation, isn't it? For iteration 2, you take the 5 points, the coordinate wise, you are calculating the average, right? That's what exactly you do.
X coordinates mean, Y coordinates mean, and you take the new mean.
Yeah, it is the same thing, right? If you do a purely statistical mean, this is the same thing. Okay? Yeah.
Okay.
And then for cluster 3, it's only 2 observations are there. So you take those 2 observations and then average for each of the coordinates you get it. Which is same as the regular mean of 2 data points, multi-dimensional data points.
Okay.
So everybody is good in this one, and it will eventually iterate to a solution. It continuously keep on doing until the average mean changes. The mean changes. If the mean doesn't change, it's over. That means it's converged. Everybody is good. Very simple, right? But there's a little bit of trick is there, but simple. Understood? Let's say yes, sir.
Yes, sir.
Yes, sir. Yes. Yeah. Yes.
Thank you.
Yes, sir.
So we accomplished that one. Okay. So if you want to find out more about distance function, there is a link here. There are all kinds of distances. So remember, distances matter to the specific to the application. Okay. It's not that application determines what type of distance to use. In this case, I used Manhattan distance because I wanted to calculate a situation where where we care for the Manhattan type distance calculations. Okay, and I showed it as an example here because different distances needs to be used. It's not always Euclidean distance. Okay. Now the next application I want to talk to you. Next topic is. There are limitations of k-means. Okay, k-means size, density, shapes all determines the k-means. So, for example, if they are distributed like this is what the original points are. If you look at it, these are the actual visually you can see that these are the groups, right? But if you looking for a k-means algorithm to develop based on where the centers fall, you are going to get the k-means to be like this, different colors. Okay. Again, visually I'm explaining it to you. So how do we solve this problem, right? In the same way, if the cluster is actually the original points are like this, and if you randomly select your random starting point, it might end up becoming like this. So this becomes 2 clusters. This becomes 1 cluster. This is what the truth is, but you may end up like this, having it like this. So what do we do? The same way, operations might be like this. Okay, and then if you put randomly your points, randomly select your starting point, it will be this one and this one. But then that will create 2 clusters in this format. All bottom points will become 1 cluster, top points will become another cluster. Also, so those are some of the what did you say? Density, size, density, and shapes of the distribution of points will determine based on the starting point will turn out to be different solutions. Okay, and how do we solve that? The idea is create lots of multiple points, starting points, not just start with 3 points. You ask for 3, eventually you'll come to 3, but you start with maybe 10. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 randomly distanced, randomly as close as possible, equally distanced starting points. You can put 100 also, not 10. Okay, but you start with a much higher number center points and create that many clusters and then keep reducing the size of the clusters. Are you with me? So you actually create 10 clusters and then from 10 clusters you go to 9, 7, like that up until to 3. Then you will get something similar to this. Are you with me? Am I making sense? For example, these are all, I said starting point should be as much as possible equally distance, because otherwise, all the starting points if you collect here, it doesn't make sense, right? So equally distance starting points more than the many times more than the required number of clusters, and start finding those small clusters and start combining them, those small clusters. Then you can see that these small clusters go together. Eventually they will go together. If you use for example combining with the hierarchy, in addition to the k-means, if you apply hierarchical here, it will come to that, but you don't even need to do hierarchy. You can continue to do the k-means here, but start with a large number of initial points, come down to 3 clusters. It will eventually come to this kind of clusters. Okay, same thing here also. Start with a large number of clusters and then come down to 3. Eventually it comes down to 3. Are you with me? Start with a large number of clusters. Eventually it will come down to this one. Same thing. Okay. And I also mentioned at one point you can do hierarchically also combine with start large number of clusters and then hierarchically combine the ones that are closer to it. Then you will get to the k-mean cluster. There are 2 ways to reach this one. One is hierarchical clustering. The other one is what is called DB scan. That's a very modern method. It's a latest method, DB scan method. That is, I want to just to get you to the terminology there, but we will finish hierarchical clustering today and we will repeat that tomorrow also. So DB clustering is very fascinating. So for example, let's say DB scan. So if the shapes are like this, isn't it very strange? It will find these shapes. If there is a elephant shape, among the woods, it will find the elephant. That is what DB scan is, okay? That will help us to do that. It's called density-based, how close the points are. Density-based spatial cluster application with noise. That's called DB scan. And there are variations to DB scan. I'm going to introduce all those things to you. Bottomless pit? No, but they all have some structure, okay? And you will see consistently they all refer to some same types of problems to solve. So it is density, how densely the points are closer, how closely. Density means how closely. So we'll come to that one. But today I want to finish, if it is possible, the hierarchical clustering. Another 10 minutes. Raja, if you drop off, it's okay. I will finish 10-15 minutes. I'll finish and we'll repeat this tomorrow. Okay. Anyway. So in the hierarchical clustering, so we want to find out, this is the points here, right? We can actually, I will show you the same 8 points I have here, right? I'm going to show it to you. How does it work out in the hierarchical clustering? Okay. Again, we have to remember distance calculation, right? In this case, we are going to use Euclidean distance. Okay. Euclidean distance means direct diagonal, not axis based. Axis based, not axis based. Okay. So the same collection of 8 points, we want, what does that mean to say we get 3 clusters here? So the idea is that, we find out the closest points first. The closest points are 3 and 5. They're the closest. And 6 and 5 is also almost probably close. Okay. But the point is 3 and 5 is closest. 6 and 5 Next joins, next closest to this is 6 and 5. That's what this one is. 6 and 5, which is same as 6 is, because 3 is connected to 5, 6 is also connected to this at a higher level, slightly higher distance. I will talk to you about that, what is meant by slightly higher distance. So 4 and 8 are closer. 4 and 8. Where is 4? S4. It's 4. 4 and no, this is the fourth point. This is 4 and 8 are closer. Okay. Next distance. Okay. After this may be exactly same. This may be exactly same as 3 and 5. But the point is that's what it is. The exactly same as this. That means this vertically the distance is same, almost same, right? If I want to put a line here, it will be almost same distance. Okay. You see, it's the same distance. The height distance is the height. Okay, height axis. This is called the distance. So it is the same distance, but it is at a different place. That's why it is getting separated. It's at a different place. But next to next closest to 3 and 5 is 6. Next closest to 4 and 8 is 1. See, 4 and 8. Next closest is 1. Between 3 and 6, 3 and 5, next closest is 6. But then at a higher level, much higher level, when I come to the distance of 2.5, something like that, 2.5 or 3, in this case 2.6, this level, then 2 and 7 are getting connected. 2 and 7, these two are getting connected. But the distance between this and this is different, bigger than this distance. Remember that. Okay, 3 and 5 bigger than 6 and 5, bigger than 8 and 4, and so on. That's why it comes later. At a higher level, this new structure comes in. Are you with me? So how do we find this one? This is the kind of pictorially shown how they are all coming together hierarchically. How do we get it? Okay. So basically, we calculated we do a calculation of distance matrix, all those Euclidean distance values between every one of the point to the other point. That's why it's a matrix. Every one of the points within these 8 points, I calculate the distance between one point to the other, one point to the other, and so on. Okay. So this is giving between point 2 and 1 only. I didn't give 1 and 1 because it will be 0, isn't it? 1 and 1 will be 0. So I can calculate that basically using an R dist function. If you say dist, it automatically calculates. I can calculate any type of distance, but the default is the Euclidean distance. So that is d11. I plot, and then I do very basically plot H clust d11. It does this to me. Okay, hierarchical H cluster means hierarchical clustering. Use the distance matrix d11. Do the hierarchical clustering using the function H clust and plot it. Then that's what I get. So when the distance becomes 6.5, all the points are connected. That means the whole things are connected with the unit of 6, with the unit of 7.2 or something. Okay, with one unit of 7.6, it's all connected. By unit of 7.6, that's a maximum. All points are connected. So let's do the calculation manually. That's what we have to do and go through that. So the way to do that is, again, the same thing now in a different slide I'm showing it to. It's called single linkage. Okay. So I had defined different linkages. One moment. And I'm going to use single linkage. Once again, clustering. Okay, given a distance matrix, we said that we can calculate which are closer and which are not closer, right? So if you take a look at it, this is the distance matrix for this actual data that we did, 8 points for the k-means, right? Same thing we did. Okay. So we are going to use what is called single linkage and solve the problem. That is the minimum of distances among all the points. You take the minimum, you select a point and then find the minimum of minimum. Okay, that's what it is. So I have a definition here. Yeah. So let's take this one. I think maybe I should put this one here. Okay, so this is the distance matrix. So minimum most distance is attained between 3, 5. Minimum most distance here is 1.41. You see this is the whole matrix 1.41, and it is between 0.8 and 0.4. 0.8 and 0.4. Also, same minimum distance is attained at 6 and 5. Okay, and where else it is attained? It's also attained by 5 and 3. So 6 and 5, 5 and 3. So and then 8 and 4 is also same distance, but it is at a different place. It is at a different place. Why do I say these are all the same together? 3 and 5 and 6. 3 and 5, 6 are connected because each of them having the same distance. So you can see that the picture is coming out to be like this: 6, 3, 5. It's a single, and with the method is use this single linkage. So if we find the minimum most distance between any two pairs, we consider them that they are coming together. Minimum distance between any two pairs, and the first pair is 3, 5, 3, 5, 4, 8. Which is what the number, in terms of number, identity number given to is 3548. Let's go and see the identity here. 48. 3548. One second. I talked about it here. The minimum most distance point 3, 5 and 4 at 2 sets, each with a distance of 1.41. Okay. And now, first I have to just make sure that you understand this point. Is that clear to you? Because there are 3 points having actually one. This point, 3, 5, 5 and 6, which means 3 and 5 and 3, 5, 6 are connected, right? 3, 5 and 5. This one is 5 and 6. This is 3 and 5. This is 5 and 6. So 3, 5 and 6. All those points are connected with the same distance. That means distance is becoming vertical. Remember, at a point 1.41, these are connected. Is everybody good on that one? There is also one same number. There is another number, 1 point. Where is that one? The 8 and 4, right? This is 1.41, 1.41. Okay, so only 3 of them. The next distance is different. That's not next minimum distance is the 2. Next minimum distance is 2. Everybody agrees? Next minimum distance is 2, and that is what the 8, 4 is. 3 and 5, 3 and 6. Okay, let me step back. 3 and 5 and 3 and 6 is 3, 5, 6. That is it is here. Next distance is another one having the same. That means in the vertical side, on the vertical side, we are going to get one more. That is 8 and 4 with the same distance. That is why, but it is away from here. From, they are not connected to 6, 3 and 5. So 8 and 4 is coming as a separate collection of points at the same distance. That's why these are connected together. These are connected together separately. Is that clear to you? This is first point. If you are clear about this, then you can understand quickly, why certain points come together, multiple points, why certain points come. Even though with the same distance, they are not connected to this one. Is that clear to you? It is the same distance, but they are not connected to this because there is no connection between these points to this. They are independently is the minimum. Is that clear to you? I'm going to show that to you also in another way. That is, second way is visually you saw that one. Visually you saw that one, but mathematically the numbers you saw that one. Now here is the way to make that logical. Can you mute out, please? So minimum most distance is between, I have to make sure that this is understood properly. 3, 5, 4, 8. 2 sets, right? 3, 5, 4, 8. And I'm monitoring whether those points are properly coded. 3, 8. Let's go back to this. 1 second. I just got 3, 5, 4, 8.
The first line is clear, but after that I sort of lost it actually.
1 second. There is some typo is there. That's what bothers me right now. Some typo is there because I expected 4,8 is this, 3,5, 4,8. We said that 3, oh, is that 1 second?
So,
Wait, Mom. Yeah, what is the question? Go ahead.
sir, which one is the best, sir? Is a single linkage or a complete linkage? Which one is best to do the clustering?
First, we will understand what they mean, and then we will come to the conclusion. Okay. First, let's understand this. We have 3 methods: average linkage, single linkage, complete linkage. The only difference is that, let me first understand, everybody passes through this point. Raja mentioned something, right? Start with the pair of distance, and the pair of distances gives me, 3, 3,5 and 4,8, having the minimum distance of 1.41, okay, in this table.
Sir, even I did not understand why we are taking in as 2 sets, 2 separate
So the
sets.
minimum 1.41 is, so in this whole matrix distance, it's a pairwise distance of points from one point, pairwise distance of each point with the other points. Pairwise distance of each point with other points. Remember that. That's what this matrix is about. And because it's a pairwise distance, you don't need you only need the lower triangle or upper triangle because it's a symmetry, right? So it's a distance matrix. From this distance matrix, what is the minimum value? The minimum value is 1.41 in only 2 decimals, right? Samya, correct?
Yes.
So I'm saying now I'm using the minimum distance. I'm going to travel hierarchically. This is the distance. I'm going to travel hierarchically up. When I go up, I am actually bringing in more and more points together into that neighborhood clusters. Okay, this is the neighborhood of this. This is the neighborhood of this. This doesn't become neighborhood of this until you go up to the distance level here. These are the neighborhoods here. This becomes the neighborhood of these points when I go up to the distance of 6 point something number, around 7. But around 8 point something, all are becoming into one cluster. That is the idea of hierarchical cluster. Okay. Now I'm saying this first point, how do I find out the minimum of all these things? You just look at the minimum of this. It's 1.41 is the minimum here. There are 3 1.41 minimum is happening there. And they are the point, the whatever 5 refers to is the identity point. It's not, it's not the 0.5. I'm talking about the identity of the point, right? The 5th point and 3rd point have 1.41, 5th point and 6th point has 1.41. But 5 and 3 and 5 and 6, they're all connected. 3, 5, 6 connected there. That's why they're all coming out together. Actually, it should not be really, it is higher because it's a complete linkage. I don't know whether you are able to see this one. The picture is complete here. It says that, right? I don't know. Yeah, I can't make it bigger. This means in the H class, the selection is complete. That's why this picture looks like that. But if you go and see this one, I'm still working on this one. Let's say this one. This is complete, but this one is also complete. One moment, I have to show you the single linkage. Why is that? This is the average. So let me go back to this one.
When we say they are linked, right? So because even in 8, right, we are having a 1.414 even against 8, right? 4,8. Why is that not linked? Why is only 3?
Yeah, okay. That's why. So this is why I'm not sure whether you are able to read this here single. Okay, side by side single and complete is compared here. In the single, we are going to talk about first and foremost. These 3 points are connected with 1 point. They all have 1.4 within each other. 1.41, 1.41.
Zoom a bit because it's not on slide, so I'm not able to see them.
I'm sorry.
Can you increase zoom out?
Zoom on. Okay, let's see. Is it better? There are too many things once again. Too many graphs.
Yeah,
Let me bring it front, maybe. Okay.
Or you can put it on slideshow. That's also fine.
Yeah. Okay. Yes, that's fine. Okay. So what I'm saying is, no, the 3, 6 and 3 have 1.41. 3 and 5 also has 1.5, 1.4. Everybody agrees that, right?
Yes, sir.
Okay. Now what we are saying is that, what is the purpose of this distance? It tells you at what vertical height, they become together. At 1.41, they all become together. If I say single usage, that means I'm taking out the minimum of each of the points to the other points. Minimum of minimum, like that. So it is from 6 to 3 is 1.41, 3 to 5 is also 1.41. They're all minimum and they all come together at 1.41.
So in this case, it's actually 6 to 5 is 1.41 and 5 to 3 is 1.41
Yes.
is what I am reading from the data actually.
Yes, correct.
It's not actually 6 and 3, but it's actually 6 and 5.
Yeah. It is not directly there because where is 6 and 3 should be in another direction, right? No, 6. Oh, you are saying this one 6 and 3 it is not 6 and 5.
Yeah.
1.41. 5 and 3 is 1.41.
That's what I'm saying actually.
This
Because in the cluster tendogram it's showing 635, right? Should it not be 653?
2.00. This is not coming. That's what your concern is, right? Okay.
Yeah.
That is where I am talking to you about the meaning of single. Okay, single linkage. But if I consider collectively is a complete linkage, okay, 3 and 5 is 3 and 5 is 1.41. I have to go back to the definition now. That's where I want to tell you the definition of what is meant by complete and single and average. Let me define that for you before we jump on to more advanced comparing between single versus complete. Okay, so we are talking about minimum of. So let's walk you through this one. Okay, this notes is very, very important. Okay, it turns out that there are 3 pairs that have 1.41. Okay, this is also not the one I was looking for. 1 second. I have to give you the definition of. Okay, here. Let me walk you through this one. Minimum most points are 5 and let's say this one is 5 and 6, right? Minimum most distance I start with somewhere, right? The starting point is 2 points. I start with 2 points. It can be anything in this case. So 2 sets. These are the 2 points, each with a distance of 1.41. Okay. Now you take each of these points. Okay. Now minimum of this 3.5 with respect to the other points is attained at 6. Okay. Are you with me now? This is where the issue of average and
please say again.
You take each of the points. First you take any 2 points. Minimum of this is 3, 5, 4.8. I just want to make sure. 1 second. I want to go back to the points. See, these are IDs only. There could be confusion about IDs and the point system that we are talking about. Give me a moment. Where we want to go back to that point 7, 8 points that we noted down. Okay. There may be 1 moment. I need time to locate that. Okay. These are the points we have, right? Let's write it down. Two, 10. It's one refers to 1 means 2, 10, right? 2 means 2, 5. 3 means 8, 4. 4 means 5, 8. 5 means 7, 5. 6 means 6, 4. 7 means 1, 2. 8 means 4, 9. Okay, so if I calculate, I can calculate distance matrix for these data points, which will be an 8 by 8 matrix, but it is a symmetric matrix. So I don't need, I need only a lower triangle or upper triangle. Okay, that part is clear to you. So now 1, 2, 3, 4, 5, 6, 7, 8, and then we talked about what they refer to. Let's go back to that distance matrix now. Go back to the distance matrix. And the interpretation of, what is meant by single linkage means minimum of minimum, and then average of minimum is average linkage. Complete linkage means minimum of the maximum. So let's calculate these things now. So start with the pairwise distance. Is it 3, 5? Where is this 3, 5 is here? In this box. 5, 8 is 4, 8 is there. That is number 3. 4, 8 is there. And then number 5 is 7, 5. Number 5 is 7, 5. Let's say that it is the starting point. Okay, I'm starting with a different point now. So both of them have the distance between those two is 1.41. That's minimum. Okay, everybody is good on that one. 1.41. That's the minimum in the whole matrix, and we start with that. Okay, and then we define a function called completely enclosing cover. In short, we are going to the complete definition. I don't want to go to the complete definition. Oh, joy. I don't want complete definition. I want single. I want single linkage. I want single linkage. Okay. So in this case, 7, 5. Let's say 7, 5, which is the fifth point, right? That's the starting point. I'm saying 2 sets each have 5. 8. Once again, please. 6, 4. So 8, 4, 4, 8. No, it says 8, 4, 8. Where is the 4, 8? Distance points 4, 8. 3, 5. Wait. 3, 8, 4, 8. Oh, okay. So we have so this is the 1.41 is attained by 3 and 5. The points 3 and 5. That's what I'm saying. This refers to point ID. It's not the data point. It's a point ID. Okay. So the distance between the point ID 3 and 5 is 1.41. The distance between 4 and 8 is this one, 1.41. 2 sets, each with 1.41. Now I take this collection, 3 and 5, this and this, right? I take that, and then I find out the minimum with respect to what? Other points, point index. I take this one as a starting point and find out what is the minimum distance of each of these 3 and with respect to this and 5 with respect to this one. That is attained by 6. Do you agree with me now? Raja and Soumya? Somebody?
Sir, I can't understand.
Okay. Is
I
this
did not get that, sir.
okay? 1 second.
The 6 part.
I'm saying these two indices. You take these two indices index points, right? 3 refers to an ID to a particular data vector, right? 5 refers to a particular. It's an ID for a data vector. Okay. And I'm saying both of them have the same distance, 1.41. 5 and 3 has 1.41. 8 and 4 also has 1.41. We will come to the complete solution. Let's just follow this one for this single linkage we are going to talk about. So 3 and 5 and 4 and 8 have both 1.41. Now I take this collection 3 and 5 and find out, what point it has at what point it has the, not what at what point. I find out the distance between the index to 3 to the rest of the index points and 5 to the rest of the index points. And it is attained among this collection. It is attained at 6. Either one is okay. But I'm finding the minimum of that. So it is attained by 6. Do you agree with me? Now, Sharanya.
So that 1, 2, 4, 6, 7, 8 are all P1, P2, P4 and
Yes.
sir?
Yes, exactly.
Okay.
These are all indices. These are all reference point. These are not the vector point. That's why it is given in double bracket. These are indices. So I take each of the point and find out where the minimum is here, which are the 5 point with respect to the minimum this year, and it is attained by 6. Either one, it doesn't matter to me. I know that 3 and 5 are, have 1.41, and I try to find out, take 3 and find out its distance with each of this one, and take 5, find its distance with each of this one, and find the minimum of that. That is what the single linkage is. And it is 1.41 again. So they all come together. Is that clear to you, Raja? And
no, actually.
And interestingly, I can start with 5 and 6, which is what, again, 1.41. That is probably, Raja, you are worried about, right? Well, you started with 1.41, and then you said the next point is coming out to be 6, that has the minimum of minimums here, right? I take the minimum of this point with respect to this, and the minimum of this point with respect to this, and that minimum of minimum attained by 6 with respect to 6. With respect to 6, and it is 1.41. And it will not change. If my starting point is 5, 6, that is, I start here. So here it turned out to be 3, 5, 6 as the all having 1.41, right? Algorithmically think like this, not the visually looking at it, algorithmically, right? And then, even if you start with 5, 6 as a starting point, you will get the 3 back into the collection. That is my point. But the method is same. Now I will say 5, 6, index only 5, 6 with respect to what other index that has the minimum, and it will be 1.41. That's why whatever the starting point, whether I start here or start here, they will all turn out to be one group with the minimum value 1.41. Now the next question is, where does it come 8 and 4 come in, because that's also next point, right? 8 and 4. But it didn't come, when I calculated this minimum of minimum among the indices, minimum of minimum, 8 did not come out. Remember that. It is the minimum of minimum for a different pair, that is 8 and 4. That's why it comes in separately here on the right side. This part needs to be clear. What am I trying to do? I'm taking the index. Index refers to a multidimensional point. And by calculating the distance matrix, I am talking about the indices here only. And which point, each index refers to a point, multidimensional point. Which point is closer to which point? That's all I'm looking forward. I started with initially 3.54 because that is the 1.41. And then I checked, okay, between 3 and 5 it's 1.41. And then I take 3 and find out what is the minimum with respect to other points. Okay? And nothing is there. With respect to 3, I don't get anything else. But if I take the next 5 with respect to this, that it turns out to be the minimum is attained at 6 with respect to the index 6. Pointer index 6, multidimensional point index 6. So that's why they all have 1.41. They are all connected at the same height. At the same height. Height refers to the distance. At the same height, they are all connected. Now,
sir, why didn't they come into the picture, sir?
No, I'm sorry.
Why are we not using 8, sir?
Coming, I'm repeating the second time. I'm going to say, okay, so why it doesn't come into it? we are talking about minimum of, okay, we start, algorithmically I start with 3.4. I could have started with 8.4, I don't know, 8 and 4, right? That's minimum, starting there. But it will not connect to the other points. It will just stay, that's it, that's one single point. Let's start with the 8 and 4. So now I have 8 and 4, that's the starting point here, right? 8 and 4. So I can connect. So 8 and 4. This is the point we are talking about. So we are going to talk about 4 and 8 here instead of 3 and 5, right? 4 and 8. If you do 4, minimum with respect to 1, 2, 3, 5, 6, 7. Is there anywhere I get what is the minimum I get here? I took 4 and 8, right? 4 and 8 means this one, this point. What is the minimum I get here? Minimum is 3.6. I will come, before I go to the 3.6, I have to cover other distances like 2, 1 point, other 1.41, and so on. There is no other minimum here attained here, right? 4. I take 4, 8. 4 with respect to this one, there is nothing. There is the lower number than that number. That is 2 is there, another 1.41 is there. So 4 is not coming to play. There is no other point that connects to the 4. Okay, and then 8 is here. 8 with respect to the rest of the points is this. 8 with respect to the rest of the points is, other than this, we're talking about 8 with respect to the rest of the points. 8 with the rest of the points is, other than this is, nothing else is there. Okay, so it is 2.23 is the next distance, and you'll have to wait for that. Okay, so that's why the 8 and 4 fall separately. It is not getting connected to 3, 5, 6. Is that clear to you? So, Saranya? 8 and 4 is same.
Yes, sir.
But it is not connecting to 3, 4, 5, 3, 5, 6. That's all I'm saying. Read this very carefully and interpret this. This is all you need to understand. And then now I take the 4 and 8. Here it is calculated. So the minimum, explicitly I'm calculating here. 4 and 8, I take this one with respect to any one of those, because it's not happening with the 3, 5, 6. So anything else, that next distance is 2.23. Means the moment 2.23 is reached, 4.8 is connected with 1. 4.8, because the minimum is attained with 1. 4 and 8. 4, if you take the 4, with respect to 4, the minimum is here 3.6. 8 with respect to 1 to 7. 8 with respect to 1 to 7, minimum is attained at 2.23. Okay, why do you want to consider 2.1, 1, 2, 7? Because the other points are already covered here. Okay, with the 1.41, the other points are covered. With 1.41, sorry, 1 moment. Oh my goodness. With 1.41, hold on a second. With 1.5, with 1.41, okay. With 1.41, already these points are covered. So 8 and 4. I have to only work with the other points. 8, 4 with respect to 1 to 7 only I have to work it out. But 1 to 7, out of that, 1 is coming first by this minimization. And then next, 4.81, I covered this 4.81 as a group, right? Now I am going to find out with 4.81, okay, 4.81, with each of 3, 5, 6, having attained 2.23, having attained 2.23, actually, with now I have to find out with respect to this group. So 8.41, how much distance it has, this one, and that is attained at each of these points. What is the minimum distance it is attained? That is at 3.6. That's what this says. So whatever you finish it, you have to work with only remaining points only. That's why I'm taking here 1 to 7, for example. So read this very carefully, this slide. It's a little bit confusing. One probably, I don't know, maybe because the index, you have to think these are all indices. These are not points in multidimensional space. These are indexes. These are referring to the rows. Okay. And it is systematically walking you through the minimum of the next distance, minimum of the next distance, minimum of the next distance. And that's the way to, agglomerate, bring them together. That's the way to bring them together. Agglomerate. That's why it's also called. That's why it's also called agglomerative clustering. We keep on, aggregatively. We keep on adding this agglomerative clustering. So we will go through this tomorrow also one more time. These numbers are referring to the ID of the multidimensional point. And I'm saying find the minimum most anywhere you start with here, minimum most, and then keep on adding what is the next point. That is where it comes here. Sometimes it could be same, then it becomes exactly on the same level. If it is not same, but at a higher level it is getting connected, that's what is happening here. For example, 4 and 8 is connected to the remaining point, because I already covered 3, 5, 6. Okay, the remaining points 1 to 7, it is attained, minimum is attained at 2.23. It is attained with 1. That's why 1 is coming next at 2.23. Still remaining is 2.2 and 7. So before 2 and 7 are connected, we find out how much these among these with respect to this, what is the minimum most distance. That is where 3.5, 3.6 comes into, and that is where it is. All these things are connected to this one. I will repeat this tomorrow also, but ask me question now. I think we have spent repetitively so many times. It may frustrate you otherwise. Ask me question. Shaumi and Saranya.
No doubts, sir.
Read this slide very carefully, okay? No notes. What did you say? Sorry.
No doubts, sir.
Cannot hear. Repeat.
No doubts, sir.
No doubts. Okay. So
No doubts.
Sir,
as long
this
as
is Rakesh.
each index, I'm sorry, 1 minute. I keep repeating this. As long as
Yes,
each index, then you'll be fine. Go ahead. Please repeat. Raja, somebody said that.
This is Rakesh. Okay, I'm clear with this. I can understand this. What I don't understand is in k-means we used Manhattan distance, right? So here we use Euclidean distance. So is it like always we should use k-means for k-means we should use Manhattan?
No.
For this we should.
No. Depending upon. I said, let us use. I don't know whether you heard that. Let us use Manhattan distance in this case. We can use. It's an example of using a different type of distance. That's how I started.
Okay.
You could have used Euclidean distance there also.
Okay. So situations. So will we cover the situations? Will we using both?
No, depends on the application. You have to decide as an analyst which distance you have to matters to you. Which distance matters. Often Euclidean distance is fine.
Okay.
I said as an example only because there are so many different distance metrics. In fact, if you remember it's also it's not really called a distance, it's called a loss function. Actually, loss function is different from distance, but they can be connected. In least squares, Euclidean distance is connected to the loss function, right? In least squares, in regression. But
that was my question, because in the map thing you showed, I can understand the Manhattan distance.
Okay.
But in a space, Euclidean distance I can visualize, but Manhattan distance I'm not able to visualize in a graphical space or something like that. Okay, maybe.
That's why I actually showed you 1 second, Manhattan distance calculations.
Yeah. In that map thing I can visualize, but
I think probably that I agree with you. In practice, how do I know which distance to use under what condition? That takes time, because you have to understand about the connection between the application and the data points.
Okay.
All data points don't mean the same thing. I want you to remember this also. All the time, all data points don't mean the same thing. For example, if your data points are always minus or plus one type classification. It means something else compared to continuous variables, right?
Okay.
So that comes only by practice of using multiple applications, and then you have to grow into the profession. Like even in the if you're doing CA, I'm talking about what is it, chartered accountant. That's where they go through kind of incrementally learning it, right? And then you are initially a associate, and then you become a fellow, and so on, right? So because it requires a certain amount of practice, experience, and connecting those. There is no tabulation. At least I don't see it yet. Maybe we can create one. These are examples of 5 different examples with 5 different distance functions. That would be cool. Okay.
Okay.
Nothing like that. But maybe in the process of completing this, I'll work with one of you to just make that tabulation. But I have to do a little bit of research to make sure that we create that. Okay. So it depends on the data and application, what distance you use. Most of the times, Euclidean distance are very useful. But later on, you will see support vector machine in machine learning, where we will use Euclidean distance again. Most of the time, we as humans mostly in the beginning evolved with Euclidean distance. Not even, I don't think even Euclidean distance, probably some kind of a mistaken Manhattan distance. Okay, not Euclidean distance. Euclidean distance came out later on, because Pythagorean theorem said the distance between 2 points is square this one, square this one, square root of that, sum of it, right? That's what the Pythagorean did. Euclidean distance is the same as Pythagorean distance, right?
Yes, because in this map, in the Manhattan map you showed, there is no path between the 2 points. But in the distribution space, how there will be no path? That is that is the thing.
You mean path, like a
no, the path. You said to go to this point and this point, there is no path. So we have to take the Manhattan distance.
No path, yeah. You cannot cross over, right, over the building. Yeah, the Manhattan is the rest of the place are buildings.
So that thing in the distribution space, how there will be Manhattan? Why there will be no path?
You're asking other situations. Where do you? What does that mean? Is that what your question is? In real life?
No. While doing clustering, we visualize the data in a distribution path in the distribution space, right? So what is the need of using the Manhattan distance in that? Because we can easily calculate the Euclidean distance. That's what if I see an example, I will get to know that.
Yeah. We just have to be very specific in terms of what kind of distance we can use this. And most of the time, Euclidean distance happens. Now, I want to impress on you that that's not the only distance function we use. I gave as an example Manhattan distance.
Okay.
And it makes sense if I say walking through from here to there, because you cannot walk diagonally.
Yeah. Yes. Okay.
So that's it. Okay. Any other question? Soumya?
No questions, sir.
Yeah. So the only confusion can be that, these are all index of the points, not the point itself. When I say 3, 5, it's within double parentheses because it refers to index, not the 3, 5 is not the point. Okay, remember that point only. Then you will be fine.
Yeah, I was also taking it row and then column wise. So that was why I was getting a little bit confused.
Yes, that's also possible. That's where you have to use this writing that I have here. This is always an interesting challenge that we go through with students. That point that how do I calculate this? And I taught you only so far single linkage. Single linkage means minimum or minimum. If you take average of the minimum, okay, then we are talking about average linkage. Okay, if you are talking about the complete minimum refers to minimum of the maximum. minimum of the average, minimum of the maximum, minimum of the minimum. Sorry, I might have switched the word. Minimum of the average, minimum of the minimum, minimum of the. Always it's a minimum that matters. Eventually, it's a minimum that matters. Okay. So read this particular page carefully. Think about it. I understand, Charanya. It is a little bit. It is. It's a kind of little bit, articulation wise, it's a little bit confusing. Maybe more confusing. I want to go back to that page. But nonetheless, it is important that once you clarify that, you'll be fine. It will stick to your brain permanently. Okay. So the complete linkage is this page. Don't worry about it. We will review this again. Okay. Is everybody good so far? Rajan, you are saying something, Raja. I didn't hear you. You want to repeat? I'll quit. I think most likely he has left. Okay. Anybody else? Raja? Shaktivel?
Nothing from me.
Okay.
I was speaking on you, this is Raja. It's saying 4,8 is 1.414, right, in the table. So why we were not using that in the beginning, right? We tried to go with 5,6 and then 1.41, and then we came to 2.23, right?
Yes.
2.23, and then finally 3.6 is where I lost actually. How we got the 3.6 until 2.23 I was able to follow. But again, there the question was why did we actually not use 4,8 earlier? Or maybe even if we use 4,8 earlier, we may still come to the same number, right? Probably.
Among this, yeah, it will come to the same number. I mean, if you start with the 4.8 so as a starting point, it will not get connected to this unless you go into a bigger distance. That's what the point is. You can start with 4 and 8 also as a starting point. So you'll get to this coming together. But you are looking for the next point that will connect with this one, isn't it? So on the right side, I'm talking to you. So I'll make it bigger if you want. So what I'm saying is, so 4 and 8, if you start there 4 and 8, this will not get connected until you come up to this distance. That's the point. They are together. These are together, and 6 and these are together to one of these. Either one or it doesn't matter. These are together. These are together at the same level. But this and this will get connected only at a higher distance. That means this is far away from this collection of points. That's what it means. So once you fix this, once you start
as per the dendrogram, right? Okay, not by just looking at it.
Not by looking at, because the looking at alone is not enough. You have to prioritize at what time you have to connect to the next point. At what time, at what distance. Time is not the right word. At what distance you have to connect with the rest of the points. See, when I go to 8 and 4, let's say I start with 8 and 4. I say, okay, they are at 1.41. They get connected, right? At that distance, they are close. They are in the same cluster. But then I keep increasing the distance, right? But before, why do I keep increasing the distance? I want to know what is the next point to connect to this one. Okay, so I have to find the distance between 4 and 8, and I can do all the other points. Nothing will be closer. First one that comes to closer to this one is 1. If I compare this with the rest of the points, I take 4 and compare with this one. I take 8, compare with this one. Okay, all this one. But they will be, one of these will be the closest to one of these. Either 4 or 8 is closest to 1. Before I come closer to these things. That is the point of achieving this discussion here. Did I make a better clarification now?
Yeah, I think just let it settle in.
Yeah, think about it, roll it over a few times. Every one of you think about it, and read this one very carefully. I just want to make sure these typings are all very perfect, because I don't want this by any chance. Any typos here, as far as I know, no. Perhaps this semicolon with the 2.23 is not perhaps clear, because I didn't use this before. So I take 4.81. I'm saying this 4.8 is getting connected to 1 with the distance 2.23. Okay, but that with respect to each of these points, for example, these are connected to this one. These are all connected together at 2.23, and this collection with each of these turns out to be the minimum is 3.6 with each of these 3, 5.6. So because they are all together here, that 3.6 they get connected. That's what it says. So and all these things are getting connected with the 2, 2 and 7, which has the distance 2 and 7 has what? 2 and 7 has 3.16. At this point, they are getting connected, but they get connected to the rest of these points at this distance, 4 point something. So read this one carefully. There may be a little bit of confusion here. What is this notation? This simply means they all have, the minimum distance is attained at 2.23. Okay. But this collection 4, 8, 1, the minimum distance is attained with respect to 3, 5, 6 at 3.6. That's what this means. So with that meaning, you listen to this and read this. It will take time. So don't get frustrated. That's all I want to tell you. Don't get frustrated. It will take time because these terminologies, languages, phrases are used in a particular way, and which you would not have used before. And nobody will use this kind of thing in normal life, right? But it is connected to some kind of an algorithmic thinking. How can we create steps that the machine will execute? That's what the algorithmic means. How can we create steps to achieve with minimum resources for maximum benefit? That an algorithm means use minimum resources, achieve maximum benefit. And you do that mathematically, given a collection of data points. And how do we do that? Is a systematic set of steps so that a computer can do that for you. And these are the systematic steps that a computer will execute for us. So I take your moment, but once you nail this one, the systematic pathway, then you'll be fine. It won't get out of your mind ever. But until you achieve that to your satisfaction, it will not get in you. We will cover this again one more time tomorrow. Okay? Don't get frustrated. Don't get frustrated. Thank you very much. Is there any other question? We will call it a night today. Day today. Okay. Yes.
Practical session
I think you have to ask them. Maybe.
And it's already nearing 8 o'clock. So.
Yeah, it's very close to half an hour only missed. Okay. I did spend a lot of time, but that's okay.
Everyone?
So, can we meet tomorrow? Everybody ready? Tomorrow? Sharanya?
Yes, sir.
Let me see.
Yes.
Let me see.
Yes, sir.
Yes, sir.
Smiley face are bottomless.
Yes.
Rajan? Oh, good. Thank you. Good. Excellent. Rakesh? It will take time.
So we'll have a practical session
Don't
tomorrow.
get frustrated. It will take time. You have to think about it many times. I think about regression even now. Is there any other way of interpreting and so on? I did this for 25 years. I still think about it. So it is not anything new. Don't feel bad. It takes time. It will take time because our brains are not tuned naturally to do this kind of things. It's an evolution in thinking, evolution in intelligence, right? Am I making sense to you? So it may look hard for you, but it's just a matter of practice. It's like music, right? Music is not easy to achieve. Is it easy? No. Take a violin and try. No, it won't come. But after a while, it is so nice to hear, right? Beautiful. Likewise, intelligence was also like that. Let's work together, continue to hammer on this one until we get it. Okay. Everybody's good?
Yes,
Say
sir.
like this.
Yes, sir.
Sharon, yeah. Good. Okay. Shaktivel. Gaushali.
Yes, sir.
Soumya.
Yes, sir.
Good. Raja. Great. Thanks a lot. Let's continue to hammer this. We are not going to give up. Let's continue to hammer this. Thanks a lot. Bye, everybody.
Thank you.
Take care.
Thank you,
Thank
sir.
Thank you, guys.
Bye.
Thank you, sir. Thank you,
Bye.
everyone. Bye. Bye.
Right.
See you tomorrow.